today is a continuation of Wednesday's notes. We got through sine and cosine, but did not get a chance to do tangent, so that's what we're going to focus on today. Make sure you pay extra careful attention because the tangent problems do require a bit more work, a bit more finesse. Before we do a problem, I do want to bring up an important word I'm going to be using, and this is kind of what makes the process a bit more difficult. That term is conjugates. Conjugates are binomials with opposite signs. Reminder, a binomial is a polynomial with two terms, hence the word bi. A few examples here just to kind of refresh your memory. We did use these briefly back in last semester during the complex numbers unit with the number I. We would use conjugates to solve problems. So an example of that would be 1 plus 3i and 1 minus 3i. That rings a bell. Remember seeing that even briefly. Those are conjugates of each other because one is a plus and one is a minus. And then the next example is what we're going to be using today. You're going to see that in terms of radicals. So let's say we had negative 2 plus the square root of 5, negative 2 minus the square root of 5. Those are conjugates as well. I'll reiterate this point again later, but I'll go ahead and say it now. Notice when we go from one to the other, only one sign changes. So on the first pairing, it was the sign in front of 3i, and then on the second pairing, it was the sign in front of the radical. The two stayed a negative in both forms. You change the sign on whatever you're trying to cancel out, and obviously we want to cancel out a radical. That's why we're going to have to do this when we get to that point in the problem. All right, let's see an actual example. Find the exact value of tangent of 225 degrees minus 60 degrees. Before I set up the expansion, let's go ahead and talk about tangent of both of those angles. If you remember Wednesday's notes, we're going to be plugging numbers in to replace those. So let's just go ahead and do that part now, as tangent requires a bit more work. 225 degrees. The point at that angle is negative rad 2 over 2. Negative rad 2 over 2. You can get that from the unit circle. And reminder, this point is cosine sine. Cosine's the x value, sine is the y value. And tangent is equal to what over what? Yeah. Sine over cosine. We're going to use that relationship here. So it's not as simple as just pulling out one number or the other as it is in the sine and cosine problems. We have to make a fraction out of it. This is what makes the problems a little more complicated to solve. Sine over cosine. So we have negative rad 2 over 2 over negative rad 2 over 2. You can keep change flip here, but that's not necessary. A number divided by itself will always give you what? 1. This is going to be 1. So tangent at 225 is 1. And let's repeat that process for 60 degrees. 60 degrees and then 30 degrees as well. These are not going to be so nice. 60 degrees, 1/2. Rad 3 over 2. Again, we're doing sine over cosine here. So we have rad 3 over 2 over 1/2. You are more than welcome to keep, change, flip, but conveniently every point on the circle that has a fraction, the denominator is 2, so this will work every single time. When you have two fractions that are being divided, if their denominators are exactly the same, those will always cancel out in the keep, change, flip process. So one kind of shortcut here, since these both have the same denominator, you can go ahead and cancel those, and the resulting numbers are your new fraction. So that's going to give me rad 3 over 1, which is just rad 3. Okay, we've kind of done the work ahead of time. Now we will do the expansion and plugging things in. Tangent of 225 minus 60 equals, and we'll set up our expansion using the formula from the slider. Tangent of 225 minus tangent of 60 over 1 plus tangent of 225. Tangent of 60, it's multiplication here, so there's no symbol between those two. If you want to write a times symbol, if that helps, you can do that. And now we will substitute. Tangent of 225, we got 1 for that. Minus tangent of 60, we got square root of 3. On the bottom, we have 1 plus tangent of 225, which was 1, times tan 60, which was radical 3. Next, I'm going to simplify that just a tiny bit. 1 minus the square root of 3 over 1 plus, and then if I multiply that out, obviously that's still going to be 1 plus radical 3. We would like to be done at this point, but we can't be. Why can't we leave our answer like that? What's the problem with that? Yeah. No radicals on the bottom of a fraction. Top is fine, bottom is not. So this square root 3 here is a problem. We need to remove it. We're going to do that using the conjugate. That's why I showed you that earlier. So I'm going to make a couple notes here. And actually, before I do that, for space, I'm going to write out the conjugates. Now, we're doing the conjugate of the bottom. We don't care what the top is, whatever it turns out to be. So the conjugate of the bottom, you change the sign in front of what you want canceled. We want the square root canceled, so we're going to change this to a minus. 1 minus the square root of 3. And you must do the same on top and bottom. If you do two different things, top and bottom, you're breaking an algebra rule. It's not allowed. And it's just a coincidence that the top happened to be that, because some students get that in their heads that it's whatever is on top that you multiply. That is not always the case. So I'm going to make a couple of notes here. Can't have a radical in the denominator. Multiply by the conjugate. of 1 plus the square root of 3. When you multiply these, do these carefully. Some of us kind of let some of the algebra rules go out the window when we get to the harder problems. We're foiling here. So we're going to multiply top and bottom. We're going to have 4 multiplications there. Top first, 1 times 1 is 1. 1 times negative rad 3 is negative rad 3. Negative rad 3 times 1 is also negative rad 3. On this last one, be extra careful. Mistakes are pretty common here. Negative rad 3 times negative rad 3. First, it's going to be a positive. And as we discussed Wednesday, a radical times itself is just going to be the number underneath. It cancels out the radical. So that's just going to turn into a regular 3. On the bottom, 1 times 1 is 1. 1 times negative rad 3 is negative rad 3. Rad 3 times 1 is positive rad 3. Rad 3 times negative rad 3 is negative 3. Watch those signs on those. Got a few more steps here and then we'll be done. Combining like terms here on the top. We have 1 and 3. That gives us a 4. Negative rad 3 minus rad 3. Think of these as like adding when you have x. It's the same concept. We have a negative 1 in front of both of those. All you're going to do is just combine the numbers in front and then keep the radical 3. That's not going to turn into a radical 6. You don't add those numbers. So we have negative 1 and negative 1. That's negative 2 rad 3. On the bottom, we have 1 minus 3. That's negative 2. And we have negative rad 3, positive rad 3. Negative 1 plus 1. Those cancel. And that should happen. If that does not happen for you, then you did not choose the correct pair of conjugates. So you'd want to go back and fix that. All right, so we've got one more, technically it's 2 more steps. These are reducible, but I like to separate them into 2 fractions first just to avoid mistakes. So let's do that. Let's split this up into 2 separate fractions. 4 over negative 2. And I always put a plus in the middle and then just carry the sign over with the next fraction. Plus negative 2 rad 3 over negative 2. And then we simplify. 4 divided by negative 2 is negative 2. Plus these negative 2's cancel, square root of 3. So the answer came out pretty nice, but the work to get there, it's a bit. And reminder on this unit is very convenient that you're able to check your answers pretty much on every single problem. So I'm going to type in the question and the answer, and they should match. Tangent of 225 minus 60. And then negative 2 plus the square root of 3. Ooh, those are not the same. Hold on, a mistake has been made. Oh, thank you. I'm like, I had this from yesterday and it was right. Okay, let me fix that. Thank you so much. I appreciate it. Okay, there we go. Not that much. Okay. Thank you. All right, I didn't make a mistake. I just typed it in wrong. There we go. Verified. That answer is right. And your tangent problems, for the most part, that's the kind of answer you should expect to get. The problems don't vary a ton. So if you make a major mistake and get something wildly different, you will know. Questions on this process? Okay. I'm going to do one more, and it's the harder version of the tangent problem because it uses a variation of 30 degrees, which is not so nice. Once I show you this, I've shown you everything. Example number 2. Find the exact value of tangent of 45 degrees plus 30 degrees. Just like the previous problem, I'm going to find the tangents first, do that work ahead of time. 45 degrees. That's the point square root 2 over 2, square root 2 over 2 on the circle. You're going to find that you're like the 45s and any variation of them. Those are the nice tangent values. Tangent equals, they're the same number, top and bottom. So if you haven't already gathered, this is going to be 1. $30 degrees. And it covered up my circle. Where'd you go? There you are. Square root 3 over 2. 1/2. Tangent equals 1/2 over square root 3 over 2. Just like in the previous problem, as I said, when you're dividing the two fractions, if the denominators are exactly the same, you can go ahead and cancel because keep, change, flip, that's what will cancel out in that process. That leaves us with the fraction 1 over the square root of 3. You can technically leave it like this for now since it's not the final answer. However, I find that the work, it looks nicer if you go ahead and rationalize this. So I'm going to go ahead and rationalize that as well. We need to get the radical off the bottom, so we're going to multiply by that radical on the top and the bottom. So we end up with square root of 3 over 3. Now we can expand. Tangent of 45 degrees plus 30 degrees equals tangent of 45 degrees plus tangent of 30 degrees over 1 minus tangent of 45 degrees, tangent of 30 degrees. Filling in, tangent at 45 is 1, plus tangent of 30 is square root 3 over 3, over 1 minus 1 times square root 3 over 3. One plus square root 3 over 3 over 1 minus square root 3 over 3. And hopefully you can see why this problem is a little not so nice compared to the last one, even more so. You have fractions, top and bottom, inside of this entire fraction. That's not ideal. So I'm going to show you an algebra trick that is a very nice way to get rid of these fractions completely. If you want to cancel out this denominator, and thankfully they are the same on the top and the bottom, we're going to multiply the top and the bottom of this fraction by 3 to get rid of the 3. So multiply by 3 over 3. Whatever that denominator is, that's what you multiply by. Had I not rationalized earlier and I kept this, it would have been square root 3 instead. That's why I wanted to go ahead and rationalize. Reminder, when you do this, you're multiplying the entire expression by that 3. So we're distributing here. Distributing, we have 3 times 1, that's 3. And then we have 3 times rad 3 over 3. This first time I'll do it the, quote, long way. Will get us plus 3 radical 3 over 3. And then on bottom, 3 times 1 is 3. Minus, again, that'll give us 3 radical 3 over 3. Three plus, and then those 3's will cancel out and we'll just get square root of 3. So as I said, we're basically doing this to cancel the denominator, so those will always cancel if you choose the right number. So the top is what's going to be left. 3 minus, again, those will cancel, square root of 3. And now we're kind of back to where we are at with the previous problem, where now we have to get rid of the radical on the bottom. So same thing, we're going to multiply by the conjugate. And again, we're doing the conjugate of the bottom, and we want to cancel out the square root, so we need to change the sign in front of it. 3 plus the square root of 3. You will never change both signs here. If you change both signs, it will be incorrect. So 3 plus square root of 3, top and bottom. And again, don't forget to fully FOIL through there. Three times 3 is 9. 3 times rad 3, that's positive 3 rad 3. Rad 3 times 3, that's again 3 rad 3. And then rad 3 times itself is just 3. And on the bottom, 3 times 3 is 9. 3 times rad 3, that's 3 rad 3. Negative rad 3 times 3, that's negative 3 rad 3. And negative rad 3 times positive rad 3 is negative 3. Combining like terms on the top, 9 plus 3, that's 12. And then 3 rad 3 plus 3 rad 3, again, just add the numbers in front. That's 6 rad 3. On the bottom, 9 minus 3 is 6. And then the positive 3 rad 3 and negative 3 rad 3 will cancel each other out as they are supposed to. Again, if they don't at this point, then a mistake has been made. Lastly, we need to reduce, and I'm going to separate those first to avoid mistakes. So we have 12 over 6 plus 6 rad 3 over 6. 12 divided by 6 is 2. And then the 6 is canceled. 2 plus rad 3. And last but not least, check with the calculator. So the question was tangent of 45 plus 30. And we got 2 plus the square root of 3. And they match. So we're good. As you can see, that answer looks almost identical to the previous problem. The sign in front of 2 just changed. So again, a lot of these answers are going to look alike. So if you get something wildly different, you'll be aware a mistake has been made. Outside of checking with the calculator, that's another way to know you made a mistake. So just kind of something to keep an eye out for.